Hello viewers, in today's session we are going to discuss two important integrals involving the Dirac delta function, right? So viewers, in our earlier videos we have discussed a lot of problems related to Dirac delta function. So here once again we are taking up these two important problems involving the delta function, and here to solve these two integrals we are going to make use of one important property of Dirac delta function. So let us start. So here let us first take this integral, right? So here we have this integral. Let us rewrite or rearrange the terms inside the integral. So we have 0 to 2 pi. Then we can write x square delta of cos x, and here we have dx, right? So now here we see that we have a function that is cosine x inside the delta function. So what we will do in such cases, we make use of an important property of delta function, which says that delta of some function, say f of x, is equal to sigma I from 1 to n, and here we have delta of x minus xi, and then here we have the absolute value of f prime of xi, right? So this is the property which we are going to use in these two integrals. So here we have delta of cos x, so this function may be taken as f of x, right? And here this function may be taken as some function, say g of x. So now the situation is 0 to 2 pi, and here we have g of x and delta of f of x. So now what we do, let us take this function f of x and let us find out the roots of this equation, that is f of x is equal to 0. So here f of x is cosine x, so we have cos x is equal to 0. Now this is a trigonometric equation, and this equation has infinite number of roots, but here we see that we have the limits, that is x varies from 0 to 2 pi, right? So we have to consider only those roots of this equation cos x is equal to 0, which lies within this interval, that is 0 to 2 pi, and we have to neglect all other roots, because in for the other roots the delta function is 0, right? So when cos x is equal to 0, we have only two values of x for which the cosine function is equal to 0, right? So x is pi by 2 and 3 pi by 2. So this is 90 degrees and this is 270 degrees. So cos x is equal to 0 implies two roots, x is equal to pi by 2 and 3 pi by 2. So now let us denote these two roots by x1 and x2. So x1 is pi by 2, x2 is 3 pi by 2. And now let us find the derivative of f of x, right? So f of x is our function cos x. So the derivative f prime of x is given by negative sine x, because the derivative of cos function is negative sine function. Now let us compute the values of the derivative at these 2 points. So we have f prime of x1 is given by minus sine x1. So we have f prime of pi by 2 is given by minus sine pi by 2. So sine pi by 2 is 1, so we have minus 1. Similarly, f prime of x2 is given by a negative sine x2. So f prime of 3 pi by 2 is given by minus sine 3 pi by 2, that is equal to minus, and sine 3 pi by 2 is minus 1, so we have plus 1, right? So we have obtained the derivative of the function at these two roots. X1 and x2 are the roots of this equation fx is equal to 0, and here we have considered only the two roots which fall between 0 and 2 pi, right? So now let us find out the value of delta of f of x from this property. So delta of f of x can now be written as sigma I is equal to 1 to 2, because here n denotes the number of roots of this equation. So here this equation has only two roots, so n is equal to 2. And here we have delta of x minus xi divided by mod of f prime of xi. So now taking I is equal to 1, we have delta of x minus x1 over a mod of f prime of x1. Then we have plus delta of, taking I is equal to 2, we have delta of here x minus x2, and here mod of f prime of x2. So now x1 is pi by 2, and here we have mod of f prime of f pi by 2, and here we have delta of x minus x2. x2 is 3 pi by 2, and mod of f prime of 3 pi by 2, right? So now delta of f of x is equal to delta of x minus pi by 2, and here mod of f prime of pi by 2 is mod of minus 1. Then we have delta of x minus 3 pi by 2, and mod of here we have 1, right? So now mod of minus 1 is 1, and here mod of 1 is 1, so we can now simply write delta of x minus pi by 2 plus delta of x minus 3 pi by 2, right? So now the value of delta of f of x is given by this expression, and let us substitute the value of delta of f of x in this integral. So now we have 0 to 2 pi g of x, which is x square, and here we have delta of x minus pi by 2 plus delta of x minus 3 pi by 2, and here we have dx. So now we can write this expression as a sum of two integrals. So this is 0 to 2 pi g of x delta of x minus pi by 2 dx plus 0 to 2 pi. Then we have g of x delta of x minus 3 pi by 2, and here we have dx, right? So now from the definition of delta function, we know that if we have the integral minus infinity to infinity, and here we have a function, say f of x, or we can take g of x, right? So let us take the function g of x, and here we have delta of x minus a dx. Then the value of this integral is given by the value of this function at this point, that is g of a, because we know that the delta function gives the value at only this point, that is x is equal to a, right? So the spike, it exists only at this point x is equal to a. So the value of this integral is given by the value of this function g of x at this point a. So this is g of a. So here in the first integral, the value of a is pi by 2, and in the second integral, the value of pi a is 3 pi by 2. So here we have g of pi by 2, and here we have g of 3 pi by 2, right? Now g of x is our function x square. So here we have pi by 2 square, then we have 3 pi by 2 square. So this is pi square over 4. This is 9 pi square over 4. So now we have here 9 plus 1 10. So we have 10 pi square over 4. That is equal to, this is 2 5s are 2 2s are 5 over 2 pi square, right? So where's the value of this integral is given by 5 pi square over 2. So now let us consider this integral, right? So here let us rearrange the terms here. So we have pi by 4 to 3 pi by 4, and here we can write x cube, then we can write delta of cos x, and here we have dx, right? So what we have done in the first integral will follow the same steps. So here we can take this function as our function f of x, that is equal to cos x, and let us take this function as g of x, that is x cube, right? So again I will make use of this property of Dirac delta function. So let us first find the roots of the equation f of x is equal to 0. So we have cos x is equal to 0, and if we solve cos x is equal to 0, we'll get an infinite number of solutions. But here we are interested only in those solutions or those values of x which lies within the limits, that is pi by 4 to 3 pi by 4, right? So pi by 4 is 45 degrees and 3 pi by 4 is 135 degrees, right? So when we solve cos x is equal to 0, we'll get only one value of x where cos x vanishes, that is cosine x is equal to 0, and that value is pi by 2, that is 90 degrees, right? And 90 degrees or pi by 2, it falls in the interval, that is it belongs to the interval pi by 4 to 3 pi by 4, right? So we have to consider only one root because we are restricted in the interval pi by 4 to 3 pi by 4. So now we have x is equal to pi by 2. So let us denote it by x1. x1 is pi by 2. So now let us apply this property. So we have delta of f of x is now given by, see here I varies from 1 to n, and n denotes the number of roots of this equation f of x is equal to 0. Now here we have only one root, so the value of I remains only 1. So we have simply delta of x minus x1 divided by a mod of f prime of x1, right? So let us differentiate this function. So f prime of x is given by minus sine x, and at this root f prime of x1 is given by minus sine x1. So f prime of x1 is minus sine pi by 2. Sine pi by 2 is 1, so we have minus 1, right? So now the absolute value of f prime of x1 is given by here simply 1, right? So this value is 1. So now we have delta of x minus x1. x1 is pi by 2, and here we have mod of f prime of x1 is simply 1. So this is delta of x minus pi by 2, right? So now this integral I, it takes the form pi by 4 to 3 pi by 4, and then we have x cube, and then we have delta of cosine x and delta of f of x, or this is delta of cos of x, that is equal to delta of x minus pi by 2, right? So now this function is our g of x. So as we have just discussed, the value of the integral minus infinity to infinity g of x delta of x minus a dx is given by a g of a. So here the value of a is pi by 2, and the value of this integral is now equal to g of pi by 2. So g of pi by 2 is pi by 2 cube, right? So here we'll take x is equal to pi by 2. So pi by 2 cube, that is equal to pi cube over 8, right? So viewers, the value of this integral is given by pi cube over 8. So this is how, by making use of this important property of Dirac delta function and this definition of delta function, we can solve these type of integrals.